What's up everybody, welcome back to another video. Today we'll be learning how to convert from standard form to vertex form. Now, learning how to convert from standard form to vertex form and vice versa is something useful to know when you're graphing quadratic equations. And as you can see in the image below, today we'll be learning how to convert from the form of y equals ax squared plus bx plus c, which is standard form, to y equals a times x minus h squared plus k, which is vertex form. So in today's video, I will walk you through one example and show you what you need to do to convert from standard form to vertex form. And then I'll give you guys the opportunity to try the last two problems on your own. So let's begin today's lesson by starting with problem number 1. And here it is, x squared plus 8x minus 7. That is our quadratic equation given to us in standard form, and we want to make that into vertex form. And converting from standard form to vertex form is as simple as completing the square. That's all we have to do. We just have to complete the square. So let's start off by setting this equal to 0. So we get 0 equals x squared plus 8x minus 7. And now we want to add c on both sides. So we add 7 to both sides. And then we result with 7 equals x squared plus 8x. Now, if you learn how to complete the square and you remember how to do it, you should know that in this step, you have to use a formula. And you need to use that formula to find the box value, to find the value in the box that we need to move on with completing the square. And to find the value in the box, the formula we use is b over 2 squared. And now we know that our b value is in our quadratic equation given to us. It's 8. So we can substitute in 8 for our b, and then we can end up with 8 over 2 squared, which is just 4 squared, and 4 squared is 16. So 16 is our box value. It's the value that goes in this box. We don't necessarily have to incorporate it with the box, but it's the value we want to add to both sides of our equation. So we want to, well, that's a little messy, but we add 16 to both sides. And now we can simplify the left side of our equation, 16 plus 7, which is 23. So then we get 23 equals x squared plus 8x plus 16. Now, if you learn how to complete the square once again, you should know that the next step should be to factor the right side of your equation, x squared plus 8x plus 16. And once again, you should know that this results in a perfect square factor. And what that means, it's going to be factored where the two terms are the exact same. If you look at it, x squared plus 8x plus 16 can be factored into x plus 4 times x plus 4. But if you look closely, you'll notice that these two terms, x plus 4, are the exact same thing. These two are the exact same. So we can make x plus 4 times x plus 4 into x plus 4 squared. And our final step is just to subtract 23 on both sides. So we get 0 equals x plus 4 squared minus 23. And that is our vertex form. This right side of the equation, x plus 4 squared minus 23, that is what we get for our vertex form after converting from our standard form of x squared plus 8x minus 7. So now that you know that converting from standard form to vertex form is just completing the square, you guys can try the next example on your own. And here it is, x squared minus 6x plus 4. If you want to try this example on your own, then pause the video and have at it. Okay, let me explain this problem to you guys real quick. So once again, we know that it's completing the square, so let's set this equal to 0. So we get 0 equals x squared minus 6x plus 4. Okay, we want to subtract the c from both sides, so we subtract 4 on both sides, and then you get negative 4 equals x squared minus 6. Now the next step is to use the formula b over 2 squared to get the missing value, the value that we add on both sides. So let's do that real quick. So our b value for this is negative 6. So we get negative 6 over 2 squared. That is just negative 3 squared. And negative 3 squared is just 9. So now we know to add 9 on both sides. And over here we just get 9 minus 4, which is 5, equals x squared minus 6x plus 9. Now the next step is to factor the right side of our equation, which results to us in a perfect square where we get 5 equals x minus 3 squared. And now all we have to do is just subtract 5 on both sides, where we get 0 equals x minus 3 squared minus 5, which is our vertex form for this standard form. This is what we get after converting from standard form to vertex form. This is our answer. Okay, hopefully you guys got this problem right. And now let's move on to the last example. Now this one's a little trickier because it does involve fractions, but I'm sure you guys will get it. And here it is, x squared minus 3x minus 18. Once again, if you want to have a go at it, pause the video. Alright, let's do this last problem. We can set it equal to 0 first because we have to complete the square. 0 equals x squared minus 3x minus 18. Okay, add the c to both sides, so plus 18 on both sides, so we get 18 equals x squared minus 3x. But now you notice it comes to the point where we have to use our formula b over 2 squared. So let's do that real quick, but soon enough you'll realize that our b value is negative 3, which is an odd number. So that means it's going to look something like this. Negative 3 over 2 squared. Now this isn't an even number, so we can't really square it. But when you're squaring fractions, what you want to do is square the numerator and the denominator. So for example, negative 3 squared is 9. And then 2 squared is 4. So that means negative 3 over 2 squared is 9/4. So now we want to add 9/4 on both sides. So we get plus 9/4. And then we add 9/4 on this side as well. 9/4 plus 18. Okay. So now all we have to do is simplify on the left side, where we get 18 and 9/4 as our mixed number. And then we get 18 and 9/4 equals x squared minus 3x plus 9/4. And now we have to get to the trickiest part of this problem, which is just factoring the right side. If you take a look closely, you want to look at our b over 2 squared. You notice that negative 3 over 2 is what we get to then square it to get 9/4. Well, if we look at negative 3 over 2, you can just realize that negative 3 over 2 is basically negative 1.5. And if you look at this equation, x squared minus 3x plus 9/4, you'll realize that negative 1.5 plus negative 1.5 is negative 3. So that is a possible contender. In addition, we have to check that negative 3 over 2 times negative 3 over 2 equals 9/4, which it does. So since both of those are true, we can factor x squared minus 3x plus 9/4 into 18 and 9/4 equals x minus 3 over 2 squared. And finally, all we want to do is subtract 18 and 9/4 to both sides, but just to make it a little bit cleaner, let's make 18 and 9/4 into an improper fraction. And all we want to do is multiply 18 times 4, which is 72, and add 9. 72 plus 9 equals 81. So that means instead of 18 and 9/4, we get the fraction 81 over 4. Now we can subtract 81 over 4 on both sides, and then we finally get our vertex form, which is x minus 3 over 2 squared minus 81 over 4. And that is our vertex form for this example. So hopefully you guys learned how to convert from standard form to vertex form by watching this video, and if you did, please consider dropping a sub. In addition, check out our playlist on Math 2. Thank you for watching.